Fitness technology has introduced a new high-resolution tachometer to increase the accuracy and reliability of the Curve3 and Force3 Woodway treadmills. This video is a demonstration of the improved capability of this system. This short video demonstrates the difference in data quality between the 600 pulse tachometer and the 30 pulse tachometer used on the Woodway Force3 and Curve3 treadmills. The data displayed has been recorded using the 600 pulse tachometer. If we open the same trial but at the lower resolution, we see the markedly increased noise, particularly appearing on the acceleration signal. We can zoom in on the acceleration signal and we see that both the velocity data in green and the acceleration data in orange is quite noisy when recorded using the low resolution tachometer. If we open the same trial again, but collected using the high-res, we see markedly improved data. If we open the low-res trial, we can see the issue in the displacement data. If we zoom in very tightly on a portion of that data, we see that in fact it is stepped because it is only measuring movement of the belt every 2 centimeters, and that creates this staircase effect. If we open the same trial recorded using the high resolution, we can see that that staircase effect disappears. It's no longer evident because we are measuring the displacement of the belt at a much higher resolution. Examining the velocity data, we can see that even when highly zoomed, the velocity data is quite smooth. If we compare it to the low resolution data, this is the exact same data, but with the lower resolution of measurement of the treadmill belt distance. I have transferred the data from the treadmill trial into an Excel spreadsheet, and we have here the time and then the distance measured using the lower resolution tacho versus the higher resolution tacho. As you can see, for low resolution, it is 2 centimeters per pulse, or 20 millimeters in resolution. But the high resolution with the 600 pulse tacho has a resolution of 1 pulse every 1 millimeter. And so comparing the distance data, we see that it is changing by roughly 2 centimeters between sample times, whereas the higher res tachometer produces data which you can see is accurate to each millimeter. This results, of course, in much more accurate velocity data and acceleration data. And we see quite marked differences in terms of velocity measured using the low resolution versus the high resolution tachometer, and similarly for acceleration measured using the low resolution versus high resolution tacho. The data, I point out, has been filtered at the same frequency cutoff for both data sets. So this is the exact same trial, but recorded at low resolution versus the higher resolution. This is a plot of the treadmill displacement measured using the low resolution tacho and high resolution tacho simultaneously. We can see the difference in the data. The low-resolution tachometer produces a staircase effect, as we can see here, because its resolution is only one pulse every 20 millimeters. The higher resolution tachometer, shown in red, produces one pulse for every millimeter of belt movement, and we see a much smoother and more representative displacement curve. Recording treadmill belt displacement using the lower resolution tachometer results in significantly different data, particularly in terms of velocity and acceleration. Here we have a plot of the same trial showing the velocity of the deck of the treadmill belt, and we see in red here the resulting velocity plot for the high resolution tacho, and in blue the resulting plot for the low resolution tacho. We note that there is a lot more noise when using the lower resolution, and this is due entirely to the difference in resolution being 20 millimeters versus 1 millimeter of resolution. It does make a significant difference to the resulting velocity data, and both these data sets have been smoothed at the same cutoff frequency. We see in particular that the peaks in velocity are quite different for the low resolution, and we also see these noise appearing because of the stepped appearance of the displacement data when only being measured every 20 millimeters. Here we have a plot of the acceleration data derived from the exact same trial at the exact same point in time, and again we see the difference in the acceleration data comparing data collection using the low resolution tacho in blue versus the higher resolution tacho in red. Again, there is both these data sets are smoothed at the same cutoff frequency, so the differences in these curves is due entirely to the difference in resolution between the two tachos. Please visit our website for more information or for sales or technical support.